Hi, good afternoon, class. This is Introduction to Kinematics Equations. So really, this is just heavy on the notes. You're going to be copying down the formulas that I have put on the back board and, explain to yourself what each part of that formula is. So to start us off, you've already used this in class a bit. We have x equals x naught plus v naught times t. Remember, if you have two letters next to each other, alright, it means there's a little multiplication in between them. Make sure you remember that. Plus 1/2, oops, I want to continue that in red or black. 1/2 acceleration times time squared. So note these labels. So this is going to be your final position. So remember, x is still position, but remember that little naught means that it is the initial position, which will often be a 0 because you can start it at 0, especially when you're running your own experiment. Then we get to v, which is velocity. Remember, there is a naught on there, the little circle, so that is initial velocity. Then we have t, hopefully you know t is time. We have 1/2, which is the same as 1/2, 0.5 divided by 2. We have acceleration. And then we have, again, time. Alright, in green are going to be your units. So for position, hopefully you've noticed by now, we are always doing position in meters. So initial position is also in meters. Velocity is now we're talking about position and how long it took to get there, which will give you meters over seconds. Time will always be in seconds. Acceleration, same thing. Now we're saying how fast is the velocity changing. That's meters over seconds squared. Time, again, this is squared, so time is still in seconds, but then you will square it. Alright, so the second kinematics equation is
going to be
black. V squared equals V naught squared plus 2a delta x. So again, going over these, v is still our velocity, and that will be in meters per second. So remember, this is also velocity, except it has the naught, so that means it is initial. A is still acceleration. 2 is just 2. Oh, oops, spelled it wrong. Acceleration. And remember, x is position, but we're talking about delta x, so it's change in position. So this whole thing, delta x, is change in position. Which we can also say as the final position minus the initial position. So make sure you understand that that delta x is the same as x minus x naught, or the final position minus the initial position. Moving right along, our next equation is getting the final velocity is equal to the initial velocity plus the acceleration times time. You'll notice my t's, I try to make them curved to make sure you can tell it's not a positive sign. So as I said, v is for velocity. That is the final. This is initial velocity. So what speed did it start at? Also, we have our acceleration, and t is time. So remember, time is in seconds, acceleration is meters per second squared, and velocity is in meters per second. Next, we're getting the average velocity. So if I write AVG, I mean average. I do not want to write average the whole time. So this is essentially when we were finding the slope of our graph, except now we're doing it in formula form. So it's the change in x, which was our rise, over our change in time, which was our run. So remember, this is position, and that is in meters over time, which is in seconds, which will give us the average velocity, which we're having meters over seconds, so our units will stay meters over seconds. Next equation is a similar idea, except we're doing the average acceleration equals the change in velocity over the change in time. So this is change in velocity. It's going to be in meters per second. So remember, anytime we say change, delta means the final minus the initial. So if I've said delta V, this means the final velocity minus the initial velocity. Make sure you understand that concept. And then delta is change in time. So same thing, that's time final minus time initial. That will be in seconds. And this stands for average acceleration, which is meters per seconds cubed. Because you're grabbing meters over seconds, you have 2 seconds on the bottom. It ends up becoming a cubed seconds. Alright, so that's it for our equations. You will always have these up, but what we're really going to start working on next time is how to use them in problem solving. Yes, we're doing problems with words that you have to convert to a number answer. We will start going over that for this week, and we will continue doing this for the next couple of weeks.